Welcome to the SolidCAM University channel. This video topic is sub-spindle fixture setup. So if you're working on a mill-turn machine with dual spindles, so main spindle, sub-spindle, the setup you should have is with coordinate system for the main spindle and a coordinate system on the backside for the sub-spindle. And also you might want to put some fixturing in there as well to show how the jaws or the clamps or your fixturing, whatever you're using, is holding that part. So we're going to take a look at that in this video. Let's start by looking at the coordinate systems I'm using here. So on my main spindle, I have my Mach 1 position 1 with the Z pointing in that direction. And if on this machine, if I have a post processor that allows for it, I have a machine control operation that does a part transfer. The part will go from the main to the sub. And if it's just moving in that direction, that means the Z is in the same direction. So that's why my sub-spindle coordinate system, my Mach 2, is also in that direction. Okay, so that is my coordinate system setup. In my actual machine setup, I'm just going to make a fresh one here so we can do this from scratch. On my main spindle, I'll have my own clamping fixture there, and on my main spindle, I'm defining it as being under Mach 1. For my back spindle, my sub-spindle, I'm defining that with its own clamping fixture as well, and that will be under Mach 2. So if I click on this green icon over here, I can see my machine sim. So if I have a machine simulation, then I can see it in this window. If not, all I'll see is my clamps, my jaws, and my part, my stock and target, and also my coordinate systems there. If you do not have a machine simulation, you won't see it here. If you do, you should. Okay, so if we take a look at our main spindle, there is our main station 1. So that is the chuck face right there. That represents Z equals 0 on the machine. And there's my Mach 1 position 1. And the way that my fixturing has been done, if I just take a look at that fixture there, I have a certain size of fixture. In this case, I'm referencing the front tip of the fixture. So that's that point right there. It's clamped on the stock diameter by default, and I've given it a certain size. By default, the jaws will be set at Mach 1 position 1, 0, and then the back end should be sitting right on machine station 0. So how this particular section works is up here, we're controlling the shift from that machine 0 of the entire assembly. So I'm moving the jaws, the stock, the target all together. In this section here, all we're moving is just the stock and target relative to the fixture, relative to the jaws. So that is how to differentiate these two sections here. So in reality, I probably want my fixture to stay right on 0 because that represents the jaws that are sitting on the chuck face. And then my machine, my part 0 here, I could either use the wheel of my mouse to scroll that out, or I can click on this button here and tell it where specifically I'd like to hold those jaws. So let's say, for instance, I am turning this maybe all the way to this point here. I want to hold it from this point and then maybe an additional 1/4 of an inch. So I'll just record that Z value there. You can see that we're holding right on the tip of the part. And then let's just make this, just for simplicity, I'll just make this 175. So that is telling it that from the tip of the fixture, that distance right there should be 175. So I've shifted it by that much. So again, this could represent an entire bar stock, so that's probably being held a lot more. But the idea here is that we have independent control of where the part sits relative to the jaws, and where the jaws sit relative to the machine face. So that is the main spindle. On the sub-spindle, I also have a clamping fixture defined in a similar way and basically referencing that same direction as well. So that's why all of that looks the same. It's being held in a tighter diameter because by this point I've already turned to this diameter here, and the placement is still going to be similar to what we see on screen here. Which means that when we take a look at our sub side, we also have a chuck face here represented by BS station 1, and the Mach 2 position 1 is in there somewhere, but we're not seeing it yet because we are not looking at it until we get to this window. So the confusion is, if I were to move out my jaws, let's move those out. They are currently facing the wrong direction, and if I tell it by going to this section here, the stock is in the sub, we can see that also my stock is sitting in these jaws incorrectly as well. So there's our Mac 2 position 1, and there's our back spindle chuck face. So since the Z is in that direction, we're basically looking at it as if it's in the wrong direction. Everything's basically looks wrong. And that is because just the direction of Z. So what we can do here is, again, this section we control the placement of the jaws, stock, and the target as a full assembly. And this section we control just the placement of the stock and target relative to the jaws. The reason I bring that up is because if I set this back to 0, we know that the back face of the jaws are flush with the face of the machine. And this is setting the Mac 2 position 1 relative to the front face of the jaws. So those are the numbers we want to start as a reference point. But you'll also notice that down here we have this flip button. Now the flip button is actually just a simplification of the advanced mode here, where you could put not only shifts in the XYZ direction, but rotations around those directions. But the reason we just have the flip button is because we just need to tell it that these jaws are facing the opposite direction. And that would be just a 180 rotation around X. So that's why instead of just putting a number, we just say flip. The jaws are facing in the correct direction, but the part is not. Well, we just flipped the entire assembly just to get those jaws in the right direction. But relative to the jaws, the stock and target should be facing the other direction. So literally, they should just be back where they were before. So by clicking on this subsection here, again, we have an RX flip. Now the part sits in its correct orientation. The jaws are flipped because that's how they should sit on that jaw face. This is now how this should look on your sub-spindle. And now it's the same thing we did before. I like to have my Mac 2 position 1 sitting relative to the front face of the jaws by a certain distance. So I'll just pick Z. After doing the part transfer, I'm probably just looking to turn this area here. So I'll just grab a Z coordinate from there. And now you can see the part is shifted out by that much. And again, I can actually maybe just shift that a little bit more. So if I just say maybe a little bit more like that, let's make that 0.75 as well. And you can see I shifted it by that much. So the setup of the main spindle and the sub-spindle is exactly the same. The only thing you have to do is on the back spindle, sub-spindle, whatever you're referring to it as, do a flip and then a flip. You're flipping the jaws so that they're facing the opposite direction, and then you're flipping the part back so it's facing the correct direction. Any questions of this or anything else from SolidCAM, just give us a call at 1-866-975-1115 extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com, and stay tuned for the rest of the videos on this YouTube channel. Thanks for watching.